Find the derivative of g of x, given that g of x equals integral x to 3 of square root of quantity 1 plus t squared. Okay? dt. So this is a fundamental theorem of calculus question. And the giveaway is that we're trying to find the derivative of something with respect to x. And we have a x here and another variable, referred to as a dummy variable often, in the equation right here. And so what this is saying is find the derivative of this right there. And to do that, what I'm going to start by saying is, I'm going to ignore this part. Be like, all right, find the derivative of this. And I'm going to say that this right here is f of x, just so that we don't, I'm going to say f of x instead of g of x, just so I don't get too confused. Now, there are formulas and ways to kind of memorize this. I like to think of this more intuitively. So if this here is f of x, then this equation here, the integral of f of x would then just be the integral evaluated at 3 minus integral evaluated at x. Now this is the big part about fundamental theorem of calculus. But you use it so much, it's kind of easy to memorize, and you should know this after doing about, I don't know, a dozen or so integrals. And so we know that when we evaluate this, we're going to have the integral of f of 3 minus integral of f of x. And since we're trying to take the derivative of this, we'll want to take the derivative of this as well. Well, since they're subtracted, we can just take the derivative of each of them. And so we take the derivative of f of 3 minus the derivative of f of x. Get out my cancellation color, blue. Well, f of 3, that's just going to be a value, like 6 or 12 or pi over 3, pi over 2. It doesn't matter, just a constant. And the derivative of a constant will go to 0. So all you're left with here is this negative f of x prime. Well, we're going to have to do the chain rule. So we'll have negative, I'll write it this way, f prime of x times derivative of x with respect to x. That's the symbol for partial derivative, but you can think of it as a normal derivative with respect to x here. And that's just because the interior here was just x. It turns out pretty simple for this question because the interior was just x. But if instead of just x, we had like x squared or x cubed or x to the 2/3, then it would get a little bit more complicated. So what we have here then is this then becomes negative f of x times, and then this is just 1. So negative f of x, where we said here that this equation here is f of x. So what we're left with then is this equals 1 plus x squared square rooted. You're like, what? We did all that work and we got pretty much the same thing as was just in there. Yes, pretty much the same. And you'll be tempted to just kind of be like, okay, fundamental theorem of calculus, just take x and plug it in. Well, our difference here then was we had a negative. And if you don't have just x, if you have like x squared or x whatever, sine of x, cosine of x, tangent of x, then it's going to come out different because you'll have the chain rule involved. Which is why I like to take this and look at it step by step. You have your equation here. You take the integral of it, giving you big f of x, or big, in this case, big f of 3 minus big f of x. Your big f of 3, when you take the derivative of that, it's just going to go back to 0 because it's a constant. Your big f of x, when you take the derivative of that, you're going to get back to f of x, like so, but then you're also going to have to multiply by the derivative of the interior, the chain rule, so to speak. And then you picked up a negative as well. And so our answer then, we come over here, should be negative 1 plus x squared. And this will be the answer to this one. So this is probably one of the easier type of fundamental theorem calculus questions you get. For multiple choice, this isn't too bad because it's harder to forget the negative when you don't have the choice of it being positive. But if you did this on your own and it's just like a free response, one of the human performance traps you'd come across would be forgetting that negative there. And that's because x is here on the bottom of the integral, not the top. Long story short, fundamental theorem of calculus, try and work it out logically. Assume that this equation is f of x and work your way down, get the solution, and you'll have better luck being right more often. Thank you much. See you on the next video.